Self-supervised learning is actually one of the most promising ways to train models from data which are unlabeled. So essentially, it is behind the training, for instance, of most large language models. The training usually is based on a fake text, which is in general to train the model to predict, for instance, a specific word from the neighboring ones, from the context, or vice versa, from a specific word to predict what will be a window of words, like the two words before this input word and the two words after this input word. We don't really care of having a good classifier who is capable to predict those words, but actually we train it with as much data as we can. Okay, so GPT, Gemini are usually trained on huge amounts of data, and then we keep the model trained on those data, and we, let's say, throw away the task, and we use the model for other applications. In this way, the model learns within it word embeddings, which are actually numerical representations of the different words, which depend on the context in which they appeared, meaning that actually they will be vectors. So each word will be a vector, basically a sequence of number, and they will be encoded in those vectors according to similarity properties. So words such as dog and cat could be closer together as they are both animals. Words such as chair and table could be closer together as they are objects who often are in the same context. How do we plan to exploit it for hereditary? Well, this is a bit the central idea behind using multiple data modalities. We plan to create embeddings, so those vectorial numerical sequences, representations of different concepts into the biomedical domain, and try to identify relationships between them depending on the embeddings characteristics, identifying if maybe there are clusters of features which are related for specific concepts, or looking at the properties and the features of clusters, ideally of patients, maybe with the same pathology, having similar characteristics. Why is this important? Well, and in particular for the neurodegenerative domain. For instance, Parkinson's disease is more and more well known and accepted that despite the common symptoms, it is actually constituted by several slightly different diseases which manifest in patients in similar ways with similar symptoms but are originated by different things. Analyzing data in this way, we hope at least to set a first step towards identifying in an unsupervised way subgroups of patients with slightly different forms of this pathology, and that might have different prognosis, different time evolution of the disease, or similar things. In ALS, there are patients who basically die in 2 years, 1 year, or patients who die in 20 years. There are also very slow forms. Being capable to tell to a patient what will happen would be extremely useful.